Hi everyone. So what we're going today is we are going to do a workshop about analytics engineering. So Juan will tell us more about this. So the initial idea with this workshop, we actually planned to do it before the new year, was to pre-record some of the course content. And also, typically I do this before courses, so then we can promote the course to attract more people. People would see it on YouTube, register for the course. So the course already started, and I don't know Juan, what are your plans if you are actually going to use the content we are going to create today for the course, or you're going to pre-record it. I don't know, up to you. Maybe you can tell us more. But I want to say a few words about the course. So if you are not taking our course, and the course I'm talking about is this Data Engineering Zoom Camp, which is a course about data engineering and one of the modules there. Right now we just started yesterday, we started module number 2. So the analytics engineering module is in a couple of weeks. But the focus of today's stream, the focus of today's workshop is going to be analytics engineering. So I assume we will learn about DBT, but Juan will tell us more about the content and what we are going to learn today. But in case you don't know this course, I'm going to share the link with you now here. And I'm also going to include this in the description in case you're watching this in the recording. And right now, that's all from my side. Do not forget to like the video, subscribe to YouTube channel, like all the usual things. But now, Juan, the floor is yours.
Sure. Thank you, Alexei. Hey, everybody watching. My name is Juan. I am an analytics engineer, one of the co-authors of a book called Fundamentals of Analytics Engineering. And today I'm going to discuss DBT with all of you. So to answer your question, yes, I actually already pre-recorded most of the lessons. I will show all of you some interesting resources before we start. I figured today we can try to make it a bit complementary to the videos that are already online. But if whatever I mentioned
Would
during
be
this hour,
awesome. Yeah.
whatever I mentioned during this hour piques your interest, I'm gonna point you to some great resources. You can, I mean, nothing is stopping you from getting started with module 4, even though like currently you are in module 2, or you can wait a couple of weeks and do it. That's fine. Yes, sorry. Before we start, the big question is, what exactly is DBT? And we kind of discussed this during a webinar a couple of weeks back, but for those of you that are not familiar, DBT is, I would dare to say, a framework, best way to describe it, that allows you to do data transformations, but sticking to software engineering best practices. So I guess most of you, if you have ever worked with data, you know at least one tool that allows you to transform data. I guess what makes DBT a bit different compared to many other tools is that it comes with a lot of safeguards already included. During this webinar, I'm going to show you some of the testing capabilities that DBT has, some of the ways that it helps you building documentation for your data, some of the ways in which you can break down what traditionally used to be thousands of lines of SQL into more modular and, yeah, better encapsulated scripts. We're going to show you a lot of that. Now,
And just a note, so Juan mentioned the interview we had about analytics engineering, and we talked about many things, including DBT, and I just included the link in the live chat and also in the description. So this is something you can listen when you're commuting, or I don't know, before you sleep or whatever you do. But this is not something that requires your full attention. This is just a conversation, right? But here today, I assume we will see some code, right?
yeah. Yeah, for sure. I'm gonna share my screen. Now I'm doing it natively with Zoom. So does it look decent? Can you read it properly?
Yeah.
Okay, maybe we can make it a bit bigger. So for the Zoom camp, well, I gave you two options. One of them was to work natively with DocDB, so everything done in your computer, no need to work with the cloud, no need to create accounts. And the second one is to work with BigQuery and DBT Cloud. As I was mentioning, I kind of already recorded quite a bit of videos these ones are already public. You can find links to all of these on the GitHub repository. If you go to the README of the chapter number 4, Analytics Engineering, there is a link to all of this. Please, I cannot stress enough, we're probably not going to manage to cover today in as much detail as you can find in these videos, just because I think this is roughly 3.5 hours of content in these videos, and today it's just going to be 2. So if this piques your interest, feel free to check them out. All of the videos were recorded using the local setup, so DBT Core, also DocDB. So what I thought we can do today as a complement is to do something very similar, but using the DBT Cloud and Google BigQuery. So think of these videos as kind of a complement. If you're doing this on the cloud, this might be interesting to see me walk down through some of the features in exactly the same interface that you're going to have. For this module and for this course, we're going to be working with a dataset called New York taxis. It's actually a realistic dataset of all of the taxis that go on New York. And I can show you, for example, here the green trip data. There is some information about the trip, about who's the vendor of the taxi, when was somebody picked up, dropped off, where exactly, and then some payment information. We have, for now, these 2 tables. We have the one for the green taxis and the one for the yellow taxis. They're very similar. I already took the trouble to ingest both of these into BigQuery. There is a video showing you how to do the setup, but today I thought we will skip it because this is meant to be more of a showcase of all of the cool things that you can do with DBT. So as I mentioned, DBT is a really great tool. It allows you to do data transformations. Most of you that have worked with data transformation tools, it can be coding, things like pandas, polars. It can be graphical interfaces, things like Alteryx, things like Tableau Prep, things like Power Query, Matillion, whatever it is. DBT has some similarities in what you can accomplish, but the biggest difference is how they go about it. So they are really much more into putting safeguards into analytics. What you're seeing right here is the interface of DBT Cloud, which is the cloud offering of DBT. Essentially, the biggest difference, and there is a whole video about it, between the cloud and the core, which is the local version, is DBT Cloud really makes your life a lot easier. They do have a free tier if you want to try it out. But essentially, if you're working with this, you have already an orchestrator. So you can say, run my DBT jobs once per day. Just you can click it. Things like doing CI. So, for example, testing your pipelines before you deploy them. It can be very heavily automated without you having to do some extra steps that you can still do in DBT Core, but it's a bit more work. The interface is also a lot easier to work with. So if you're the type of person that is not very familiar with, for example, Git, what DBT Cloud does is it suggests you the next best option that you can do in Git. So if there is something that you can take away is there is the core, there is the cloud option. Both are great, but the cloud version, one, does a lot of the heavy lifting of fully deploying DBT for you. And it is a lot easier to operate if you're not very familiar with DBT and maybe even with Git. For this setup that I'm showing you right here, both BigQuery and DBT, they're both technically paid tools, but everything that we're gonna do falls into the free tier. So with the community edition of DBT Cloud, and honestly, I've had this project for a couple of months now, and I haven't really used any of the credits for what we're gonna do. So now I'm going to take us to the studio. This is the integrated IDE. This is where we're probably gonna do 80% of all of the DBT work out there. And this is kind of how it looks. I've been already doing some stuff to test that it works, so maybe let's hide it. But this is essentially it. Right here on the left, let's start in the top where it says, yeah, you can see my mouse. Good to know. Where it says version control, here they're always suggesting you what is the best Git action that you might want to take. If you think that Git and version control is overwhelming, this is going to feel refreshing. But if you're an expert using Git, you might feel that sometimes very advanced commands are either more difficult or impossible to achieve with DBT Cloud. So it's a balance. Down here in the file explorer, here is your DBT project. I'm gonna show you, and as we go, I'm gonna discuss what are the objectives of different folders right here. But just know that this is a very standard DBT project. This is exactly how it comes out of the box. I think, no, I left it exactly how it comes out of the box. I did delete some of the demo files, but this should be fine. Right here, we have a place where I can create files and edit them, similar to any editor. And finally, in the bottom, where it says DBT clean, because I was setting it up, here's a little terminal. Here you can run DBT commands like DBT run, DBT clean, all sorts of things. It is a very limited terminal in the sense that you cannot do, for example, git commands. This is only good for DBT related things. For example, if I try to do a git status, am I covering it? Yeah, I think I'm covering the terminal.
So actually, funny thing is that even though here in Zoom there is overlay, in the stream you're not there.
Yeah.
So this overlay doesn't really.
Oh, okay, that's fully fine. Yes. So for example, I tried to run a git status, which is a very common git command, and it tried to append dbt on it, and it failed. So just so you know, there is a terminal, but it's meant for dbt commands. If you, especially like if you're a power user of things like Git and you're very comfortable around a terminal and you don't like this too much, it is possible to actually set up a CLI for DBT Cloud and to fully work in VS Code and yeah, you will then have full control over everything terminal that is normal. But this can be, I know, very nice for people that are just getting started and the concept of working with a terminal and Git might seem overwhelming. So now that I walked you through the interface and some of the basic things, it is time for us to get the data, which once again is here on the BigQuery project. How exactly do we get the data here? And for that, I'm gonna go here to the models folder. Here is where we put most of our SQL files. I'm gonna walk you through some of these ones, but I do have a video where I cover in detail what each of these folders means. For now, I'm gonna open this one called staging, and I'm gonna show you how to load up sources in DBT. So we create a file. Now, how exactly this file is called, it doesn't really matter, but there is a very common convention to call it sources.yaml with an underscore, just so that it appears on top. But once again, it just has to be a YAML file. It doesn't matter how you call it. We're gonna use this convention. If you work with DBT, you're probably gonna get sooner rather than later very comfortable working with YAML files. For those of you that are not familiar, YAML is very similar to things like JSON or Markdown. It is a language in which you can create text lists. They're very good for configuration. And what you're going to notice is lots of tools are adopting this as a way to write configuration. Like YAML is something that you're going to use in lots if you're working with things like GitHub Actions, if you're working with Docker, which I believe, well, Docker Compose more specifically, you're going to be working a lot with YAMLs. So to load the sources, we simply need to type sources give them a name. This name is arbitrary. I'm gonna call this NY taxis. NY taxis. We can give it a description. Um, uh, yeah, and we will leave things like documentation later. For now, let's focus on the things that are absolutely necessary. So what is absolutely necessary to load this is the three following things. You need first a database, the schema, and the table. If you would be working with something like Snowflake or DuckDB, this is very straightforward. Just check in which database, in which schema, in which table the data is. But BigQuery does something a bit different that might be confusing to some people. If you want to work with BigQuery, what you actually need to do, the database, is the code of your project. So, sorry, the ID of your project, which in my case is SumCamp plus some numbers. This is going to be my database. The schema is going to be the BigQuery dataset, which in my case is called NY taxi. And the tables is just saying these tables right here. So because there are many of them, I'm going to do name, green trip data, name, yellow trip data. Now I believe this should be, yeah, this should be the same. I'm going to save this file. I believe, yeah, I believe everything should be fine. And to test this, let's try to open it again. Yes, okay. I made a little typo. It should be tables. And the reason I noticed that there was a little typo somewhere is because normally there is this option here called generate a model. If you are not working with DBT Cloud, you generally have to create a new file for the model. But DBT Cloud actually has this very useful shortcut that once you have defined here your YAML properly, and by properly I mean tables, plural, and everything with proper spacing. Now we can, for example, click here on Generate Model. It can take a second or two. And now this automatically generated a file containing all of our data. Now these files, we call them staging files. The idea in DBT is to work with layers, and let me walk you through some of these layers in a second. Okay, this looks correct. When I open up here the terminal, I can generally click here. And if I see a preview, that means this is correct. The data is now officially here available on DBT. Let's do exactly the same for the yellow data set. Remember, there is a green and a yellow one. We're going to talk about those differences in a second. This looks correct. We can once again do a preview with Control Enter or just by clicking this icon. And this looks correct. This looks perfect. Now that I show you how to, let's call it, load your sources inside of DBT, let's zoom back a second and talk a little bit about this folder structure. Now, inside of my models, which is DBT models are just SQL or sometimes Python files, but 99% of the time SQL files. In here, there are three subdirectories. There is staging, intermediate, and Marts. And those names are actually the DBT conventions for the Medallion architecture. You might know this as bronze, silver, and gold. You might know this as, what is it? Isles, coves, There are many ways of calling them, but essentially, this is one of the big ideas of data modeling, which is to break data modeling into three separate layers. The first layer, which DBT calls staging, but it's fully fine if your organization they call them, for example, bronze. This one is meant for the raw data. The only things you're supposed to do here in staging are very, very minimum transformation. Things like especially renaming columns, casting to the right data types. So maybe something was written as a bar chart, but in reality it's a datetime. All of that, you should probably do it here on staging. The guidelines that DBT suggests is everything in staging should be a one-to-one copy of your data, meaning same number of columns and same number of rows. And very rarely you want to deviate for this. A very nice way of describing it that I heard recently is everything in staging is optimized for your source systems. So whatever your source system is, it can be a CRM, it can be Google Analytics, it can be some API somewhere. Try to make sure that the staging layer is as close as possible to whatever you're getting from that system. The last layer is Marts. Now, and I understand it's confusing because they're sorted alphabetical instead of by purpose, but Marts is very similar to our Gold. And this one is the opposite to staging. It is fully optimized for humans. So every single thing that you have here in Marts should be impeccable, properly tested, ready to be consumed by a tool, by an LLM, by whoever is your data consumer. Ideally, everything there should have proper names. It should be very impeccably documented. And if you're doing things right, it is a really common practice that you only give access to people to whatever is in the marts, but you don't give access to things that are in staging or intermediate. And now I already explained staging and marts. Let's talk about intermediate. Intermediate is essentially everything in between marts and staging. It's not something that you want to expose to people, but it's a transformation that is a bit heavier than a one-on-one little cosmetic change of the raw data. Things like pivots, unions, some crazy joins at times, you might want to put them here, keep them isolated, make sure that if they fail, you know exactly what it's failing, but you almost never, or ideally never, want to expose intermediate to anybody for no reason. Now, I've heard good arguments for exposing staging because some people might want to audit what was the raw data like. But in reality, intermediate, that should never be a good reason to do it. And now we have right here my staging models. This was once again achieved by just simply typing some information on where to find this data. And by creating a SQL file that DBT generates for me automatically. What this is essentially doing is using a source here. This name actually comes from here. And this is the name of the table. Now, it automatically creates this CTE called renamed. The idea here is if I disagree with any of these fields, like maybe one of them is, yeah, like, let's see, for example, no, they all look good, but let's say that instead of extra, we wanted to rename this extra fees or whatever.
And
This
if
rename,
let's say we need to parse data types or something. So let's say in our raw data it's a string, but we want to parse it, turn this into a timestamp. Do we
yes,
do this in staging or do we do this in intermediate?
it's recommended that you do it in staging.
Or
What you
sometimes like truncating. So let's say you have value, but there is a lot of spaces, white space. You truncate. All this happens in staging, right? All
Yeah.
these initial simple data transformations, as long as you keep the number of columns the same, it's okay. So changing the date types, doing some simple transformations to columns, renaming, all goes to staging.
Yeah, and it's good to mention that everything that I'm telling you about staging, intermediate, and what to do there in Marts, those are DBT best practices, but these are not make or break. I'm gonna tell you exactly how DBT recommends you to do it. And in my experience, this is gonna work for most organizations, but it could be that your organization has a good reason to do it slightly differently. That's fully fine. I think all of these practices of organizing your SQL files should be ultimately helpful. But regarding casting, um, you have two options. We could either um, check, for example, here, which are the discrepancies. Like, okay, well, probably you can see that a little bit easier in BigQuery. We can analyze here, like, for example, vendor ID is right now a string. I believe it should be an integer because if we preview the data, it's just a number, it's a 1 or a 2. And it's fully up to you if you want to. I think there is no way around it. If you're working with data, you generally have to do this, what I call librarian work, of checking these data types, making sure that they're correct. Some of them are definitely not going to be correct. So you can either fix the ones that are incorrect, or you can, for example, also proactively fix everything just in case. So cast this as
Because
integer.
proactively, you mean that in case upstream data changes at some point. By upstream data, I mean the data from which we load.
Sorry, what was the
Like
question?
you said proactively cast
Yeah.
it. You mean like, okay, we have the source table, right? And what if the type in the source data changes? Is this what you mean? Like we want to guard ourselves against changes like that? Because I imagine, like, for example, this New York taxi data set, they release data monthly. But what if one day they release it as a string and another day they release it as a integer, right?
Yes. So what I mentioned is you have two strategies. You can either check column by column and determine this one is at the right type, this one is not the right type. But indeed, I think we both align that the best practice is to be super proactive and cast all of them. So if you check, by the way, there is a fully fledged out DBT project in here. We're gonna start building it from scratch in this video. But if you want to see how I would approach it, you should definitely check it out here. So for example, what you see here is I was proactive and I modify except this one right here. I don't know why I missed it. But all of them, I explicitly casted them, even if it was redundant, because indeed, if in the future something changes, I might want that discrepancy to be notified about it. And DBT has many features in which you could do that. There is one called model contracts, which I'm gonna show you later. But just for now, know that yeah, this is a very common practice. Now I'm probably not gonna do them today because it would take too much time. But this is how you would do some staging models.
I have a question for you.
Sure.
So in reality, I mean, for this particular data set, the data set is Parquet files and CSV files, right? So let's take Parquet files. Is it a good practice to load this? Because the way we load Parquet files, we tell BigQuery, hey, here are the Parquet files, please load them, right? So we first may load this to a data lake, and then from the, I mean, Google Cloud Storage, and then from Google Cloud Storage, we load it to BigQuery. Can we do this step in DBT? And is it recommended to do this step in DBT? Or this is something we do
Uh,
prior, before running it in DBT? And DBT assumes that everything is already in our data warehouse in BigQuery.
so The answer is you could do it, and there are some ways that you can potentially hack around loading data with either pre-hooks or even seeds. But DBT is not meant to. So maybe one thing I didn't mention too much is DBT it has like some very hard boundaries, which it starts once the data is already in your warehouse. So once you already uploaded this with something like DLT or Fivetran, Airbyte, whatever it is that you're doing, even with a Python script, once the data has been loaded here into your warehouse, that's when DBT starts, and it ends before you start making a dashboard in another tool.
Mm-hmm.
So they never want
We're
to,
restricted to BigQuery only, right? So we cannot go outside.
indeed, even though DBT continues to grow as a tool and expand, I think they're very fixing to never step towards ingestion, never be a warehouse, kind of like a BigQuery, Snowflake, a Databricks, and never be a BI tool. Now, it could be that maybe next year they announce something and this video is going to age terribly. But for now, that's kind of the boundary. And good to mention, you have to think of DBT more like I think it's closer to GitHub than to BigQuery. In other words, DBT does not run any of the compute. It simply sends the queries back to BigQuery, but I'm going to show you in a second how that would look like, and that will become a bit more obvious.
But to answer my question is we would have some sort of workflow where first we load data using whatever command line maybe. Like here, this is Parquet file, load them to Google Cloud Storage. Then another step in this workflow could be, okay, now from Google Cloud Storage, let's turn this into a table in BigQuery, and then DBT starts.
Correct. DBT is more a place where you put your code, and it does a bit more than that. For example, it knows how in which order to run your code and everything. But indeed, ingestion and everything, your workflow, DBT should always be a part of your workflow and not like the tool that does every single thing from ingestion and everything. Even though I think if you really put me up to the challenge, even though it's not gonna be practical, I think you can come up with some crazy workarounds to
Because
trigger
there's
ingestion
this
workflows.
SQL statement like load table. I don't remember the syntax, but basically you say, okay, there is this packet file. This is the schema, now load, right? And you can execute this in BigQuery. And since you can just copy paste this command to BigQuery and execute it there, technically you can also run it somewhere else that sends queries to BigQuery, right?
Yeah.
For example, dbt.
So yeah, indeed, you could do it. I know some people have created macros that do stuff like that, but ideally, you wouldn't really do it. You would focus more on your
Got it.
transformation. Cool. So now I want to call your attention to these crazy brackets that maybe some of you might have noticed, which says here like source and some things. And it's kind of funny because when I click here on compile, you're gonna notice something really interesting. If I would try to run this command with these brackets directly in BigQuery, it is gonna fail. But when I click on compile, and here is, sorry, here's where I see exactly the same command that was sent to BigQuery. You're gonna see that all of those brackets are gone. And now like here are like full references to the data source. What the thing that just happened is these couple of brackets, they are actually a templating language called Jinja, which you might be familiar if you have worked with tools like, for example, Django, or sometimes it's very common when they send you spam emails that instead of typing every name, they do something like Jinja for name of clients. So essentially what this does is before it runs the query directly in BigQuery, it takes a second to resolve what these brackets are actually supposed to mean. And in this case, this is what they're supposed to mean. This query here that you see compile, this one will actually run in BigQuery, no issues. And this is very powerful because you could potentially just simply type source and you can reuse exactly the same code in multiple environments. Imagine that here in BigQuery, I have a prod and a development environment. I could have 3, 4, whatever it is. If you would not be working with DBT, you would have to potentially open up these files, replace right here the environment. You will have to write some crazy Python code that finds references that are hard coded and modifies them. But with DBT, it's just smart enough to resolve this to the right environment. And that really unlocks the capability of running the same code on multiple environments, which is something that was really tedious to do in traditional SQL. Like I do remember, we're talking maybe close to 10 years ago. One of the first SQL projects that I ever had, they had 2 versions of the code. The only thing that changed was indeed the hard-coded references to the environment, because back then the SQL dialect that we work with didn't have any variables, didn't have anything. And that's just such a waste. So it's really nice that these brackets, yeah, kind of do all sorts of cool things. Now, right now I have 2 data sources. What I mentioned in the videos is I like to think that all the way here until staging, you can do all of this without knowing absolutely anything about the business that you're working with. Like, seriously, you could create sources for everything without talking to any stakeholder, without understanding what's the difference between green and yellow. But starting from this point where we move towards intermediate, I think now is the moment that it really pays off to understand the whole context around this data. This is like an example data set, so it's not that deep or not that crazy. But if you would be in an organization around this time when you're done with sources, is where you're expected to talk to domain experts, people familiar with the data, to see reports, to understand how people are using data in their dashboards, how people consume data, and to get familiar with how exactly this business operates. So let's get a bit familiar with this data set. I actually had to Google this because I didn't select this data set. This is something that has been there for years. But apparently in New York, before there used to be yellow and green cabs or taxis, they used to have a very interesting problem. And that is that taxis will just stay as long as they could in the center of New York, in Manhattan. Why? Because that's the busiest area where the most trips happen. And this would be an issue because people living in the outskirts, in the boroughs of New York, like outside of the city center, it would be impossible for them to get a taxi. So the solution that the New
Happens in
York
Berlin too.
government had, sorry?
This happens in Berlin too. So Uber cars
Yeah.
do not want to leave the center. And
Yeah,
like they are very annoyed because like when you order a taxi through Uber, the Uber doesn't show the driver where they go, and they only see it when you board the car. And they seem they look very annoyed when they discover where you go.
that's
I'm
funny.
sorry. Please
No,
continue.
I didn't know it was a thing in Berlin as well. So yeah, their solution was to create a second type of taxis, which are green. And the particularity of green taxis is they can only pick up people outside of the city center. Of course, I don't know too much about like driving taxis or something like that, but it seems to me annoying to have to pick up somebody far away, drive them to the center, and then potentially get out again, just because that's the way that the license operates. But I guess it's amazing for the people living in the outskirts to have that system. So now that we know the difference, it's time for us to already start thinking. And once again, I'm getting you familiar with the business context, but there are some other things that you should also worry about. Like, for example, how are people expected to consume this data? What types of questions am I gonna get asked? Like, do people ask how many trips in total, green and yellow? I don't care. Do people ask only for green and they never care about the combination of both? Also, it's good to get familiar with some of the common data quality issues here. And there is no, well, maybe there is a tool that does it, but like there is no way around it. This process is tedious. And in the real world, you have to do it. That's what I call librarian work. That you need to query the data, you need to preview it, you need to explore the relations between columns, which columns are mostly empty, what are the ranges between, for example, which is the first date and the last date, what are these, for example, what is the store and forward flag, or the currency. This is of course dollars, but it's good to get, or for example, this hail fee, and why is it always empty. At this point, it's really important to get familiar with all of those things to really become an expert in your data. And I think maybe we kind of spoke about this during the webinar, Alexei, but probably one of the big differences between analytics engineering and data engineering is, as a data engineer, it is fully possible for you to just take data from A to B without really caring what exactly is the data that you're transporting. I know there are people that are amazing data engineers, that they work full time and they never have to care about what's the business context or even data quality issues or stuff. It's just moving data from the data lake to a warehouse or whatever it is, and that's it. As an analytics engineer, when you're reshaping all of this data, you do need to get a lot more, yeah, you need to get your hands dirty with all of these fields, and you need to ask people what to do with this, and so on. So at this point, I am taking the arbitrary decision. It could be right or not. That probably people are going to ask me a lot for, both like how many trims do we have in total? And so maybe people will appreciate to have a union of the green and the yellow data sets. So we're going to create one right here. I'm going to call it intermediate trips union.sql. And we're going to keep it super simple. Select everything from, and remember how we used the dual brackets for source last time? Like source? That is only for sources. Everything else starting from this moment, you're going to use another type of Jinja called ref. And this is going to become a bit obvious later. Now, in DBT Cloud, you could either type this, but they do have a very handy shortcut, which is when you type a double underscore, Python people call it a dunder, you have access to absolutely everything. So I can type dual underscore and then staging, New York taxi, green, trip, data. You don't need to type the SQL inside of the ref. I'm going to save it. And look what happens when I compile this. I'm not done with my union, but I just wanted to show you real quick. It just knows exactly what it is. Now it is working with a schema called dbt Perafan, which is a schema specific to me. But those are deployment details that if we have time, we will talk a bit more in detail about deployment. Now, I'm gonna do a union. All, select everything from, once again, ref, staging, and my taxis, yellow, trip, data. Now, this command is actually gonna fail, and I think it's kind of interesting. Now, I think you can preview it, but generally the convention, no, you cannot preview it. Generally, the convention here is to already start working with DBT commands. We're gonna talk more in detail, and I made a 15-minute video talking about all of the DBT commands. But for now, I'm just know that when I type DBT run, let's look at what's happening here. So these ones passed. So these ones run properly, my staging models, and this one failed. I personally don't know why exactly. Yes, never mind. Indeed. So that was the whole point. When I type dbt run, now when I go back here to my data set, something really cool happened. And that is, now there is a schema called dbt JN Perafan with the data sources that have, this is essentially what we have in our staging models. And you see, this one is like an old one that I created for before. Let's just delete it. But yeah, dbt just created these two staging files. You can see here. Yeah, this looks correct.
So we told it to select from these tables, but when it was analyzing the SQL query, it understood, okay, like we don't want to build this whole big query. Let's materialize some of the parts, right? So it saved the things to this stage in the table, right?
Yeah.
That's cool.
So now
How do we know? Is it always doing this, or we have a way of controlling it?
controlling what exactly?
Like whether something gets materialized, whether something gets stored.
Yes.
Okay.
Yeah, but we're gonna talk about materializations in a second. So right here we have this union all, and it says that it failed because one column has 24, one table has 24 columns and the other one has 20. And I wanted to do it this way just to show you like this failing, and I kind of completely forgot about that. But at this point, and this is very common in the real world, it's good to go back and actually check the discrepancy. So, okay, what's the discrepancies between our models? And it's good to mention that the discrepancies are actually that the green data set has some extra columns. One of them is the e-hail fee. Now, what this is essentially there is an app where people can request a taxi. That app is called e-hail, or I think that's how it's pronounced. And if you do it through this app, there is an extra cost associated to it. But even in the real data, this one is almost always or always empty. I think right here is fully empty. So I do have two choices here to reconcile this difference. I can maybe come here and potentially create something, like create a column. When you start getting to this point, I think what you naturally start gravitating towards is to clean up your data. So I'm trying to do this demo kind of how you would do it in real life. So you start quick and dirty, you start exploring, but then you realize like, no, you know what? Let's take a second to make things proper. So I'm gonna clean up my data, make sure that every single identifier is on top. I think there should also be like a rate code, which this one is better to rename it to rate code ID. Those would be like the identifiers that I have. I do have some timestamps. Now this, you don't need to do it, but doing this is gonna save you so much time. I really cannot recommend it enough that you take a second or two to, of course, I'm kind of cheating because I do have like the finalized model here. But when I was first doing this, I did take my while to explore this data and to put everything into logical steps. So trip info, we're gonna put this column right here, the passenger count, trip distance, and I believe all of this is payment info, right? And of course, we have these columns that I use for the partitions. I'm gonna leave it like this. So yellow looks nice. Now I generally do exactly the same here. For simplicity, I'm simply gonna copy and paste from the DBT project. Did I mess it up? No. I did delete my partitions, which is fine. Let's maybe delete them from here as well, even though DBT recommends to keep them as one-on-one copies. And now my data looks a little bit more organized. I still should cast every single thing, but I just don't want to make you go through all of that process. And now it is time for us to find what to do with these columns. So one of the ones that are different is the trip type. There is no trip type right here. And the other one was the e-hail fee, right? So yeah, so it's fully up to me if I want to do this reconciliation right here. Like at this point, I'm more in an organizational dilemma. I can try to solve these differences in here in the staging, but I think it is kind of nicer to solve it directly here in the intermediate. So let's maybe come back to this model and try to do it using the best practices. First of all, DBT recommends you to work with CTEs and to, let's call it green trips. Yeah, there you go. And to always start by adding your sources on top. Okay. Now, this might seem like a redundant step to just add a CTE with just my sources and nothing else. But this is kind of nice because it allows you to inspect the files and see, okay, these are the sources that you're using for this. And if I compile them, I see very high on top, what do they compile to? So it is a normal tendency for people to want to simplify this and try to do it in one file. But working with CTEs is a bit nicer because if something fails, you know exactly which CTE is failing. Honestly, before CTEs were introduced, which all things considered are a relatively recent SQL development, we're talking maybe 15 years. I mean, I say recent because SQL has been around for more than 50. I remember I've worked in projects where there were no CTEs available, and then you have like a SQL script of 3,000 lines, where if it fails, it's really hard for you to know what exactly failed. But if you work with CTEs, you can isolate like, okay, this is the CTE that is failing. Let me check what's wrong there. DBT also has this saying, which is lines are cheap, but mental capacity is expensive. So try to simplify a script and make it very readable, even if it's more lines, can be nice. I think at this point, I'm going to cheat a little bit. Once again, I have another screen here to my right with the code. And What I'm simply going to do is I'm going to copy paste all of the columns. And I've decided that I'm going to service type, put a column here that it says green, so that I know exactly, okay, I did a union, but these ones are green taxes. So it's a way for me to be able to know this. And I'm going to do something very similar here to my trips, the yellow trips. I almost forgot this line. Perfect. Now at this point is worth showing you two things. The first one is the only thing I did to the green one is adding one extra column for me to identify that those records come from the green table. But I had to do a couple of interesting things for the yellow trips to match my green ones. The first thing is I created a column called trip ID that was missing. And what this column does is it contains a number, I believe 1 or 2, which indicates if a taxi has either been requested with something like an app, or if a taxi has been requested on the streets, like, hey, taxi, please stop. Code 1 means stop in the streets. Now I feel very comfortable simply adding trip type 1 to every single yellow taxi because it is legally the only way that you can stop a taxi. There is, as far as I was able to research, not such a thing as any other way to call a yellow cab in New York that is not stopping them in the street. The other one is the e-hail fee. I'm gonna cast that always. I'm gonna make it 0 always because, well, there is never a way to do it. But now this is nice because now both of my tables, the green and the yellow, they have exactly the same number of columns, and I can finally do my union.
I have a quick question for you. So
Sure.
what we're doing now, is it, would you consider this an intermediate stage?
Yes.
Uh, so this is our like silver, how they call silver layer.
Correct. DVT calls it intermediate, but I really like bronze, silver, and gold just because everybody understands that hierarchy and gold better. But yeah, so this transformation I think fits much better as an intermediate model. Select everything from green trips, from union, and now let's see if this is able to preview. Maybe I wrote a mistake. There is something there that is not correct. Depends on a note. Yellow trip data. Because they do have a slightly different name right here. But that's not a problem. Probably one of the reasons I kind of wanted to make videos on my own is because I knew that this happens all the time. That
It does.
even if you're very familiar with a framework, there's always a typo like, oh, I wrote table instead of tables. Doesn't matter if you have been working with a tool 300 years, it always happens. Operator, this one looks correct, and this one, they both look correct. Let's try to do it from scratch, see if that works. So staging NY taxi. This one is green trip data. And this one is the same, but it should be yellow. Let's try to DVT run this. Maybe it's already correct. Oh, there is probably an error right here. I might have broken something. Oh, yes, I think I did break. Let's see. I think the reason is because the GitHub project does have some mismatches here. Rate code, yes, indeed. The difference is let's hope for the best. Put location ID. Yes. Let's see in BigQuery real quick how they're actually called. Pickup location. Okay. Pickup location ID. Drop off location ID. Now I think now it should be correct. Always part of the work to reconcile little name changes. Like you would be amazed how, yes, how annoying and how disruptive it is to fix these little things in a real corporate setting. In fact, fun anecdote, I would never forget one time when I was in my first job. I had a very important data presentation and I had a dashboard and something. And that same day, like hours before, data improve surcharge. I don't know if this one exists, right? Oh, it's imp. Okay. So I had a very important presentation, and that same day, like seconds before, the person in charge of the warehouse decided to rename all of the columns, similar to what we're seeing now, like just changing some spaces, shortening up something. And when I opened the dashboard, like it simply just broke. Oh, BigQuery adapter console camp. DBT run. Let's
So
see
what
what
happened?
happens.
What happened in that meeting? Did you have to adjust all the column names, or you said,
No,
"Sorry, I'll do this later"?
there was absolutely no time. They thought I
Okay.
was dumb, and I
Yeah.
didn't. I didn't even know why exactly like things were breaking or what was happening. And later on, I realized that was the cause, and it was like, oh God, like this is why it's very important to notify people downstream when things are not working properly. Sorry, when you're planning to do a big change. I'm still something is failing. I'm not really sure. Maybe like a column here. Let's see if DBT gives me better error names here. Improvements surcharge. Yes. How did I call it? Um, improvement. Maybe in yellow it has another name. Yes. Okay, as. Now I'm gonna fingers crossed that this is the last thing working because I kind of want to transition to the next topic, which is, you already hinted at it, materializations. Which one is failing again? Incompatible. Some of them are strings and some of them are not. Okay, this is fun. Okay, maybe we can ignore this for a second. I'm gonna delete that file and later we'll do it. I want to change topics for a second and kind of come here to BigQuery and show you something interesting. So here are my staging models, and it says that the type is view. And it's kind of interesting because I didn't really mention view anywhere. And that is because DBT has something very interesting. if any of you is familiar with creating views and tables in traditional SQL, you're going to notice creating both of them requires quite a lot of code. So I'm just going to create an example SQL file. If I was not working with DBT, you generally have to create table, table name, as, and then all of the columns, call one, do the data types, and then fill out the table. Long story short, traditionally speaking, creating views, tables, it wasn't difficult, but it was quite a lot of code. But what DBT does is it has a very interesting approach, which is I have my code right here. Let's compile it for a second. Okay, it looks perfect. Yes. So DBT has here a hidden folder called targets. And this one is really interesting because it has some files, but right now I want to show you this one called compiled. I can come here, open up the green one. And we see this is exactly what was sent to the data source, to in this case, BigQuery. And there is something very interesting, and that is like by default, these things are being created as views. But what happens if I actually prefer a table or an incremental table or a materialized view or an ephemeral model? Now, different warehouses might have different materializations, but even though DBT by default creates things as views, what if I told you you're actually able to override that behavior? So let's pretend that our model here, let's say the yellow one, let's say that we want to materialize this as a table. You could do it in a couple of ways. The first one is directly inside of your model. On top of it, you need to create a config block. And by the way, DBT just created this whole block. Normally, you would create it with bracket, bracket, and so on. But if you're on DBT Cloud, you can type double underscore config, and DBT automatically will create this for you. What this little code snippet does is, let's save it, let's run it. It might take a second or two. Let's go. Now it says here that my model, this one has been created as a table. And remember, we didn't do anything to the green one, so this one is still being created by a view. So DBT by default materializes data as a view, but you're able to override that behavior either by typing a config block, in which case it's kind of tedious because you need to do it once per model. And let me tell you, right now we have two models. We failed creating the third one, but very soon it is possible to have DBT projects of thousands and thousands of models. So I don't know if you want to do it. Now, if I refresh this, I click on the wrong one. Here it is. Now you see that this one is indeed a table, which is really cool. But if you don't feel like doing that model per model, because that's going to become quite a lot of work very soon, it is possible to open up this file here called dbtproject.yaml. Now, this is a very important file. In here, you can add, well, some things that you maybe shouldn't change too much, like what happens when you type dbt clean. You can save variables. And what we really care about right now is this one right here. So right now it has like there is an example file folder, and it says everything in that example folder should be materialized as a table. I deleted that one, but I didn't delete this reference. What you can actually do is say, hey, here in my DBT project, every single thing under staging is going to be materialized as a table. DBT recommends that staging should be materialized as views, but if for whatever reason you want to modify that behavior, you could do it from here. Since we're on it, it's kind of nice that we also do something similar to intermediate. So materialize these ones as a table. And our marts, it's fully up to us if we want to do them as incremental, as materialized views, as we're gonna keep it simple and say tables. And doing this is kind of nice because what that means is that every single thing in that subdirectory or in that subfolder, like staging, this is what the default is gonna be. I can still override that behavior by, once again, adding a config block like I did, sorry, in yellow. But me personally, I'm the type of person that prefers to not add config blocks for materializations. There are some other cool things that you can do inside of a config block, like set up partitions, set up clusters, all sorts of things like that. But for now, we're gonna delete it. So that was another very powerful idea of DBT, the fact that you are able to materialize your data however you decide, either if it's a view, ephemeral, materialized view table. Different warehouses have different materializations to choose from. There's generally like 4, 6, sometimes a bit more. And it's fully up to you with which ones you work. Probably views and tables are the most common ones. In case you're wondering what is the difference between a view and a table, it is that when you create a table, tables are actually written into disk. They get like properly materialized. It is technically a file occupying space in the physical memory of your computer. And they tend to be faster to query and to work with because it's just like reading from a file. But they do have the problem that once you create a table, you do have to add one extra process to keep that table always up to date. So you need to create some sort of refresh schedule. You need to find a way to, if a record changes, to make sure that it's correct again. It can be a bit more performant, but it adds that extra overhead of always having to keep the table up to date. Now, views, on the other hand, they're never written into disk, but they're done in memory. And they're done on demand. So whenever you need a view for something, your computer creates the view on the fly. This is nice because views are always going to be by definition fresh, but as you can imagine, this is a bit slower, especially when you're nesting views, like working views on top of views on top of views. That gets very slow very quickly. DBT has some recommendations of what materializations to use. They're very reactive by nature. They say staging should always be views because those are very minor cosmetic changes. Remember, you're not supposed to do something too crazy in staging. They recommend Marts to be ideally materialized views if your warehouse supports it, or incremental tables. And then intermediate, they recommend either tables, and if tables are very slow, go to incremental tables. But different organizations might have different ways of working with this. So it's fully up to you. There is no right and wrong way of doing it. It's just kind of nice that materializations are so easy to control on DBT. And by the way, this whole decision of what should I materialize my data to, it's probably something that you might need to put some thought into. Now I am gonna continue, so I'm probably gonna. 'Cause, 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 Uh, yes. Let's go back to trips unions. Now I did remove this file, but thinking about it, I should probably have kept it. So it doesn't matter. We're gonna yellow trip data. We're gonna have it as a simple recap. Select everything from. I'm gonna do a ref. Staging and white taxi. Yellow trip data. We're gonna do the same with the green. Everything from ref. Copy here. Call it green. And just to make our lives a bit simpler, I'm going to do something that is not really a good practice, but it should be fine for today. Once again, I don't want to deal while live with all of these crazy name situations. So I'm going to do something that people don't generally consider to be a good practice, but I guess here is going to save us from anything. We're going to do a select star and then define the columns that I do happen to know are different. Remember, once again, cast 0 as numeric, as eHail fee. I know for a fact that there is never. And finally, I want to identify where a record is coming from. So I'm going to create a completely new column called service type. In here, I'm going to keep things very similar. Now, once again, this is not considered to be a good practice because you're supposed to be explicit. So type every single column out there. But because I don't want to make you walk through the whole process of me doing it, we're gonna do, let's call it a quick and dirty approach. But once again, if you're curious about this DBT project and you want to see it like fully fleshed out, you can always check the code repository in here, select everything from unions. I forgot a comma, so this is gonna fail. And now, I guess fingers crossed, let's see if this works.
And they have different names. Remember this imp? Imp. What was that? I don't remember.
Yes, some of them were. Yes, I just remember some of them were strings, some of them were. Oh God, this was such an annoying thing. Let's. You know what? I guess this didn't
Create
work out.
ChatGPT and say, hey, this is my source. I want to union them. Create me a SQL
Yeah,
query.
maybe.
Or this is something that everyone who's watching can do this.
Yeah, maybe let's just give up on this. Let's continue pretend that both of them are unions, even though I know everybody knows they're not. Let's talk about Marts for a second. And the question here is, what exactly do we put into Marts? What exactly is like ready to be presented? And I think two types of files fit the description of Marts really well. The first one is things that are supposed to be powering a dashboard. So if there is a very important dashboard in the organization, maybe like a dashboard they check every morning with sales, or in this case, like number of trips or something. What I generally like doing is I create a subdirectory inside of Marts, either called dashboarding or reporting, something like that. And in here, I create a SQL file with, I don't know, in this case, what I decided to go for this particular project is, imagine there is a dashboard that always checks the monthly revenue by zone, right? Which is just gonna be like a simple aggregation of things, but imagine that's the case. Those are generally the first type of things that you might want to put into the Marts layer or the gold layer. But it's also a very common practice, and even more common than this reporting thing I just mentioned, is to put a dimensional model in here. Now, if you're not familiar with dimensional model, which is one of the most powerful ideas of data modeling, think all data sets, all databases, they are designed in a particular way. And there are actually a handful of people in the past that have given suggestions on how exactly you should organize your data. This is a topic that I can definitely recommend you if you're into analytics engineering. Essentially, if what you aspire to be somebody that translates a business into a data set, probably learning about data modeling can be very helpful. But if you're not familiar or you don't care, there are two interesting ideas that uh, I want to share with you. The One of the principles of dimensional modeling that I think most people adopt here in DBT is to separate tables into dimensions and measures, or they generally call them FCT, like fact, and dim as in dimension. The distinction comes tables that map a process are fact tables, and tables that have attributes of an entity are dimensions. Fact tables examples are fact trips, one row every time there's a trip. Fact sales, one row every time we sell something. Fact deliveries, every time we deliver something, there is one row. And examples of dimension tables would be, in this case, vendors, one row with info about a vendor, like who's the taxi vendor, info about a customer, like sometimes not in this case, but in a real company with like phone numbers, directions, last name, corporate number, whatever it is. Those would be more examples of dimension tables. As rules of thumb, um, this is not fully the case, but it's more of a rule of thumb. Fact tables tend to be larger and tend to contain more timestamps. And dim tables tend to have attributes that you might want to modify. Like if one of your clients changes the name of their company, their address, their phone, that's something that you might want to do. These dim and fact tables, it is a really good idea for them to be tables with a very clear objective or a very clear granularity. So I think your data is much easier to work with if we will have, for example, and let's start creating them, something like a fact trips. And these fact trips would be one row per trip. So explaining what every row of a table means. So one row per vendor. And I think we should also have one for locations. Now in the course, locations is one of the things that I ask you to do, but we'll see how much time we have for that one.
I like the comment that we have in the live chat.
Sure.
For me, I think of fact tables as events and dimension tables like entities.
Yes.
It's a
Yeah,
good
indeed.
summary.
So I fact tables map a process, so it's indeed like an event. And the other one contains attributes of an entity, which I know is kind of like a very technical language, but it's kind of straightforward. Now, sometimes I do see tables like, well, yeah, like these ones. If we start exploring this, we're noticing like this one contains like vendor ID and contains info about like the place where people were. This is, if you think about it very clearly, a fact table, one row per trip. And it does contain some info on how to link that fact table to other tables. Now, these tables don't exist, like, but if you would have like a vendor table or something like that, that would be, yeah, that would be something different. Let's maybe start by creating a vendor table, one row per vendor. To do this, I would start in once again with a CTE, trips as, select everything from. Ideally, I would have loved to use the intermediate model that is kind of broken, but think even though this is not fully correct, for now we're just gonna let's do the yellow taxis, yellow trip data. So this is gonna be my source. And a vendors table would be something like select distinct vendor ID from trips, select everything from vendors. Now let's see if this works. And it kind of works, but it's right now it's just some codes. It's just sometimes 1, 2, and sometimes 4. Now I actually research, and there is actually a meaning behind these codes. So what we can do is we can maybe add a when, when statement. So when vendor ID is equal to 1, sorry, case, then this one is equal to, and I do have them written down here. Creative Mobile Technologies. When, let's maybe copy and paste it a couple of times to make our lives a bit easier. This is a 2, this is a 4, and I do happen to know that 2 is Verifone Inc. And 4 is unknown or other.
There's
Now
a
let's
data
see.
dictionary, right, on the website.
Sorry?
How did you find this? I think there was a data dictionary or like some data
Yes,
documentation.
correct. So syntax error. Sorry. I forgot to type an ent. But yes, indeed, this data, this New York taxi data, this is actually real data put up by the New York government. And there is not only data dictionaries, but there are some people that have written like all sorts of comments. And I've saw in the internet some people discussing like, hey, why does this happen? And some people in forums asking. So yes, I was able to find this from the internet. And right now we have the column. Now I should probably call it as vendor name. This approach that I came up here, now this works. This is not incorrect. But what if I tell you there is actually room for improvement? Because imagine that one of these vendors changes their name, or maybe like new vendors come in, because I think in 2024, which is the last year that I saw this data set for, they had like Lyft, Uber, all sorts of crazy vendors. If this continues growing, I don't want to have to remember that all of this business logic was in my dim vendors and have to open this. DBT has a very cool feature that I want to show you right now, which is macros. Macros are very similar to Python functions, and they allow you to save lots of typing and to encapsulate business logic. Now, if this would be Python and you kind of wanted to simplify this code, because right now this And this is mostly the same code. Like this is maybe not written in the most optimal way. Macros kind of allow you to simplify that. And I'm going to create a macro called get vendor data.sql. Now remember Python functions, you start with def, you give them a name, like my function, and then you have some arguments, arg1, arg2. This is for those of you that are familiar with Python, and then there is like some logic with finally I return something. DBT macros are very similar syntax-wise, but they contain a lot of brackets. I can once again type __ macro to already add some placeholders. Instead of def, they have this macro thing. A name, I'm gonna call this get vendor. Sorry, I called it data, but it should be names. Let's keep the name as descriptive as possible. And the only argument that I really care about is my vendor ID. So if you give me a vendor ID, I can potentially paste this code right here. Let's delete this one. I can potentially leave it like this. And then in here in my file, I can get vendor names, vendor ID. And if I didn't make any typo, this should work. Yeah, it's, oh, once again, I forgot to as vendor name. Now, this is really cool because what I just did is I encapsulated this logic. I put it in its own file, which is now here under the macros directory. And I know that if in the future I need to do something to this list, I can simply just open up this macro, put it here, and everywhere in my data that I decide to get these vendor names, it's just gonna be a reference to my macro. Now this is already working, but what if I told you that we can actually improve this? Now the Pythonic way of doing this, by the way, of course, some of you might already be asking in the, like, why don't you ingest this data directly into your data warehouse? That would be a really good approach. But if for whatever reason you cannot, you can either do it as a DBT seed, which we haven't talked about right now, but maybe some of you are familiar, or you can do it as a macro. The Pythonic way of doing this would be to create a dictionary with the names. So if I was asked to solve this in Python, this is more or less what I would resource to. What if I told you that in DBT, it is actually possible to do something very similar, but we do have to, this is not gonna be a normal dictionary. This is gonna be like a Jinja data type dictionary. I do need to write set to tell it this is a variable, call it vendors, and in here, there you go. Let's make this a bit pretty. And right here, we already have a dictionary. Now, if new data comes, I can continue updating this dictionary. But what is super interesting about DBT is that I'm actually having this dictionary is allowing me to simplify my code. I can simply do case vendor ID. So I'm referring to this variable right here, and I'm calling it inside of my code here with some Jinja. So essentially, I'm telling it this thing right here, this vendor ID with these brackets, is exactly whatever people pass me as an argument of my function. And Jinja is quite a complex language. I can show you. There you go. Here in the Jinja documentation, Jinja supports all sorts of things, variables, but it also has some very Pythonic things. Like you can do for loops, you can set up data types, you can do transformation logic inside of Jinja, like upper, lower, uh, all sorts of crazy things. DBT in particular, and I think I left that open here. Yeah, I left it open here. They actually encourage you. Well, what they say is don't go too crazy with Jinja because too many brackets become harder to read and to work with. But if you can simplify the code and apply dry principles, which is short for don't repeat yourself, then maybe creating macros with Jinja can simplify some of the things. So the approach that I have right here involves some interesting features. You see here, like the example that they give, they do have a for loop. And what we're going to do is very similar. So I'm going to create a for loop. In this case, it will be for vendor ID, vendor name in vendors.items, which are the items here on my dictionary.
This looks like Python, huh?
Yes. Now, I know some of you are probably hating me, like this
Yeah.
was very basic 10 seconds ago, and now where are a lot of these brackets going? It is fully fine if you decide like no brackets for me, thanks. But what I really just want to show you here is that with Jinja, you can build things that are very Pythonic in nature. And now I can do vendor name.
So there's a very interesting question. I'll let you type first.
Sure. No, you
Uh,
can
you
ask
finish.
them.
Yeah. So the question from Ramis is why don't we just define a JSON file and ingest it as a table?
It's like I mentioned, it is a better practice to do it that way, for sure. This is just to show you some of the alternatives that you have. In practice, it can happen that either you want to do a quick and dirty to see how something would look. Like sometimes I add extra data to test something. This is one of the ways that you could do it. Or sometimes it happens that you don't have access to writing tables in the data set. You
Hmm.
could do it this way. For now, I just want you to take three things from this exercise. One is writing in your data, like all of these reference tables, it is always a much better idea to write them back in your warehouse if you can. But two, DBT macros exist. They're very similar to Python functions. They allow you to encapsulate logic and put it somewhere else. And three, for those of you that are more advanced users, it is possible to build some crazy things. So essentially what I did, and it's okay if you're already lost in all of these brackets, is I took a dictionary and I'm doing a for loop that simply searches for my vendor ID here and returns the vendor names. So now let's see if I kind of broke it or if it's still working.
There is a question from Ramis
Sure.
too. Would it not be simpler to directly use Python? Is it even possible to use Python directly in DBT?
Ish. So yes, it is possible for you to create Python models. They are not supported by every single warehouse, but by most of the big ones like BigQuery for sure, Snowflake, Databricks. You can write Python models in DBT.
So it would be UDFs, right?
However, there there is something kind of interesting here, which is like all of this craziness that we're doing. let me show you. So all of this craziness that we're doing, the moment that we type dbt compile, dbt is transforming all of this into whatever it is that needs to happen. So the
I assume
advantage
this
of
will
doing
be
it this way,
faster, right, than just
sorry?
executing. I assume this will be faster because it's native SQL. You don't need any, because
Yes.
the moment you have Python in your SQL, there is some back and forth between SQL and Python, right? But here it's native SQL.
So there are two ways of seeing this. On the one hand, I would love it if I could define my macros using 100% Python. That would be amazing. But there is still some interesting advantages of doing this because this is just getting compiling to text even before this query gets sent to the database. So sometimes doing it like this can be a bit faster. And when I'm compiling this, I'm getting this list. And I could potentially type, I don't know, this is not correct anymore, but imagine that this, I'm just gonna type it just to see what happens. Save it. And now when I compile it again, so now the code has changed, and this is way before it gets sent to the data warehouse. Now, you could argue that maybe this was not the most amazing use of macros, but I do have another example that might be interesting to you and maybe more realistic. When we see here our data, huh, okay, and maybe the other one. God, I'm so happy I recorded this because I really don't feel like debugging all of this with all of you in front, but okay, fine. Yellow is working properly. Now, one of the things that you might want to calculate is how long was how long was a trip in seconds or in minutes or whatever. But I think minutes is kind of reasonable. Now, you could potentially in here create a new column like, yeah, here I could create it, but this would not be very clean. And also, like, I might need to define this. So yeah, I don't know the BigQuery syntax, but it's generally something like datediff. Let's look it up. Datediff in BigQuery. I'm googling it because the syntax of datediff changes in every single warehouse. Even how datediff is written. Okay, there you go. So this is the BigQuery syntax of datediff. And granularity, I want minutes. Now, I don't know if this is gonna go. Let's give it a try to see if this is correct. So I cannot pass minutes. It's a yes, okay. I think this is it. Oh, I click on compile instead of run, but that's okay. Let's see if I finally hit the syntax properly. It's required but found minutes. Day, week, month, quarter, year.
And maybe we need time diff.
There
Oh,
is a okay.
yeah.
Daytime diff on BigQuery. Okay. Probably some of you might know, daytime functions are always the funniest part of everything SQL. because they change in every single warehouse. Okay, and let's see. Minutes. Okay, not plural. Well, let's just say we managed to get this working. Now, instead of, there you go. Instead of having this defined somewhere, let's call this as trip duration in minutes. I need to add a comma, of course. Might take a second. Yeah, there you go. Now we have our trip durations. Now, for whatever reason, some durations are 0. This could be like a data quality issue, but yeah, half an hour. Oof, this one is a bit tricky. I don't know if that's correct.
Well, that's the beauty of this data set, because we have
Yeah.
cases like that.
When you analyze the data quality issues, you notice quite a lot of interesting things. Now, I could potentially leave this, but then I need to also do exactly the same in green. And there is a chance that this deviates or something happens. So this is also a good example for a macro. My rule of thumb is if a transformation is very complex, if there is a chance that two transformations that are supposed to be the same slightly deviate, or if a transformation takes way too many lines, in my particular, I know that might be controversial. If a transformation takes more than 4 lines, I simply create a macro. And I know that every single thing, like get trip duration, SQL, and I know that if I want to change the definition, it's in there. In fact, when I'm working with real clients, one thing that I really like about macros is that you can, for example, when you don't know what to do about something, I will give you a good realistic example. We have some trips that are very long. They seem to be wrong. If I find myself that I want to go to a stakeholder and say, hey, do you want me to simply calculate this, or do you want me to put safeguards? Like if the trip is less than 0, then no, or if the trip is more than so many minutes, then no. It is possible that they tell me, yeah, that sounds reasonable. Let's add these boundaries. And then as the logic continues to grow more and more complex, I know for sure that it's just here in my macro. So pick up daytime, drop off daytime, and the logic is simply gonna be date diff drop off daytime and minutes. Now I could potentially add another argument like date part and by default make it minutes, but let's not complicate it ourselves. Now for now, it feels like an overkill to do this, but once again, it's kind of nice to put it in a macro if you also want to sanitize the input. So for example, if like if the day trip is less than 0, then turn it into a null. Or if the daytime diff is more than so many minutes, and turn it into a null. So it's kind of nice that you can put all of that logic in there. For now, and for this course, I'm gonna keep it very basic in here, nothing too crazy. And get trip duration. And if we did it correctly, this should work. How much more time do we have, Alexei?
How much time more do you need?
No, it's more like I mentioned, we do have like 3.5 hours of videos here. So I'm curious if we manage to cover one or two topics or if we round it up here.
I have a question for you, and also
Sure.
I see this question from the audience. Like, how much of this content that we saw now overlaps with what you already recorded? Like, is this something that we should watch in addition to the content we already have?
Yeah, I think so. Maybe the answer is right now. My idea is to show you a little bit what it's like to work with DBT, show you the interface, talk through some of the aspects. If you think that this was very interesting and you want to get more familiar with DBT, these videos cover most of the topics we covered to no, all of the topics we covered today in a lot more detail.
Yeah.
And also some topics we didn't manage to cover today. For example, we covered macros, but we didn't cover seeds. We didn't cover DBT tests. We didn't cover documentation, packages, DBT commands, and so on. So
Mhm.
these ones, you can definitely check them if you want more detail. Every single video in here covers the NY dataset. So this is going to be relevant for your homework if you're doing that module. You can, if you're not a video type of person, you can also check the DBT project right here. We have been trying to rebuild this from scratch, but you can also just like check all of these ones. This one is already a bit more completed. Here is the union that we tried to make, but it didn't work out. And here is some other interesting things, also using packages. You can try to reverse engineer this DBT project and try to see how it works. If you want to learn a lot more about DBT and you don't care too much about like the NY taxi dataset, I definitely recommend you to check all of the DBT courses. Yeah, no, not this one. So DBT in learn.getdbt.com, they do have a lot of courses. These ones are always up to date. Some are really good. They do have some advanced ones that I really like deployment, testing, incremental models. This one I check so often that I actually. So if you want to learn DBT more as a tool, check these ones out. DBT is a very big, let's call it framework. It covers testing, it covers documentation, deployment. It is a command line tool that has, I think, 10 different DBT commands that you should know of. So there is plenty of things to learn. But if I want you all to take something from this whole DBT thing is as any type of data job, you are going to be in the situation where you're going to want to do transformations, either because you want to capture business logic, like these vendor names as an example, or because there is something wrong about your data that you need to clean. DBT is an amazing place to capture all of those cleaning steps and all of the transformation logic because it, well, it has quite a lot of stuff to cover, but it has quite a lot of interesting guardrails, like, for example, testing. And you can leverage DBT packages, which are packages built by the community, similar to how you would do in Python loading packages. It contains quite a lot of interesting things to make sure that your SQL logic is correct. So especially if it's very important for you that your SQL is 100% right, DBT is a really good place to work. That's that's kind of the things where I would let you.
Yeah,
Um,
thank you, Juan. Just to understand for me the difference between the content you already have and this one,
Yeah,
do I understand correctly that in the module you don't use DBT Cloud, right? And here you use.
correct. Yes.
Okay.
So I did record a video explaining the difference between DBT Core and Cloud into a lot of detail. There is also a page here, DBT Core and DBT Cloud. Maybe I can find it easily. No, okay, I didn't find it. So everything is being very well documented. The short answer is DBT Cloud is a lot more beginner friendly and it does a lot more of the heavy lifting, especially when it comes to deployment, which we didn't really cover. You can work with either. In fact, we're still at a point where both tools are very similar. I don't I don't see like a massive difference working with one or the other in terms of difficulty.
Mm.
However, it might be kind of nice for um it might be nice for those of you that want to get more familiar with the terminal and get more used to actually working with VS Code to try the local setup. And for those of you that don't want to bother too much, and because the truth is DBT Cloud is a bit easier, and all of the courses that you find on dbt.com, they're going to be on DBT Cloud. So my line of thought was, I'm 100% sure that people working with cloud, they're not going to get stuck because, well, it's much better documented. There are more courses around it, and it also simplifies some of the development. I try my best to also highlight, like, at this point when you do this in DBT Cloud, this is going to happen, and in DBT Core, you have to do this extra step. But I'm just confident that no matter which of the two choices you go for, the experience should be very, very similar.
And the order, so because probably in the course has more content, right? So
Yeah,
here, so
yeah,
first watch the course, and if people want to get more experience with DBT Cloud, then this video, right?
yeah, exactly.
Got it. Okay. Yeah, still know.
Maybe.
Okay, maybe one more question. Why use DBT and not just normal storage procedures and cron jobs?
Yes. So, traditionally speaking, SQL work was done with stored procedures. And those of you that are not familiar, what essentially that is, and I might be oversimplifying this, is telling SQL all of these commands, run them in an all goes or nothing way. So if all of them succeed, run this. If not, if something gets stuck in the middle because there is an error, please fail the whole thing. Don't even bother. And this was very nice because sometimes you want to transform a table, write a table, and then do something else. There is no point in writing the table if that something else is going to fail. So that was the way of working. Stored procedures, they do have a couple of things that make them a bit harder to work with than DBT.
Remember having
The,
to read those things like it was an oracle and it was a nightmare. Like they haunt me in my dreams, these
yeah,
storage procedures.
the first one is stored procedures are generally one purpose only. So it is very common to have way too many stored procedures that are very similar. The fact that DBT allows you to use Jinja and templating means that you reduce the amount of code. So DBT files tend to be shortened than stored procedures. Two, uh, what was it that I wanted to mention? Yes, stored procedures, they're generally saved directly into your warehouse and they're run by your warehouse. But what this means is that it's very hard to DevOps stored procedures. So most stored procedures cannot natively be safe in Git. What is very common in teams that work with stored procedures is they copy and paste. So they modify it directly into their warehouse, like let's say Oracle, like you just mentioned, Alexei. When they're done their copy, they paste that into Git and then hope that they don't drift so that nobody modifies the stored procedure without like saving it into Git properly. DBT is fully Git native, so this will never happen to you. Whatever is in your Git and all of the benefits of Git, like reverting, checking the diffs, all of that. DBT has a command line tool which allows you to do some very interesting things. Like I think CI is the most interesting one. You can potentially set up DBT in a way that please run my whole DBT project or this part of the project. If this fails, don't allow people to overwrite the code. Doing things like that with stored procedures are either impossible or very difficult. And we can go to differences, but maybe like to simplify it is DBT thinks of a lot of software engineering best practices like automated testing, version control, CI/CD, different environments. All of those things are much better integrated to DBT than to stored procedures.
And I was just checking the documentation from Oracle on stored procedures, and I
Yeah.
have PTSD now. So I see we have more questions, but we
Sure.
unfortunately don't have time.
Maybe.
So
Okay.
the best way for this would be to just ask it in Slack, and then we can answer.
Yes. So maybe the call for all of you is once again, all of those videos are there. Today life happened, but all of those videos are a bit more into detail. So if any topic you want to learn more about it, either the official DBT ones or the ones that I made are there. The DBT project is there. I am also available in the Slack. Feel free to message me if you have a direct question. Feel free to connect with me on LinkedIn if you want. I'm also quite often there, and I'm there to help you. I'm really happy about this initiative. It's I don't know. I think it's a really cool idea to teach people, help out. So if you have any questions, DBT related or analytics engineering related, let me know. I'm always happy to help you guys out.
Thank you, Han. It was really nice to see all these things in action. Oh, yeah, we know that live demos are live demos. Happened to me many times too. So thanks a lot for doing this, for preparing the materials, for doing it for 2 hours. I cannot imagine how difficult it was. Like,
No,
keeping
it
all
was
this
short.
context in your head. And thanks everyone for joining us today. Uh, so yeah, have fun learning DBT. It's a cool tool, and yeah, you can always find us in Slack, and yeah, have fun.